Here, the question is to finding the volume of a solid obtained by rotating the region bounded by the given curves. So let's figure out what is the region first of all, then we'll do the rotation. The region is bounded by these two curves, so I'm going to try to plot these. Y equal to x square is a parabola. So let's say this is y equal to x square. Y equal to 2x is a diagonal line passing through origin. So let's say this is y equal to 2x. Okay. The region bounded by these two is this highlighted region. So that means I need to rotate my region, which is bounded by this straight line and this portion of the parabola. I only need to rotate the region. I don't need the remaining parabola or the line. Now, the rotation is about the y-axis. So this is my y-axis, vertical axis. My rotation is about this. So the first step is to imagine how the solid will look, and then we'll try to find the volume of the solid. When you rotate this region across y-axis, to help you draw that, try to draw a mirror image of the shape in your y-axis of rotation. Axis of rotation is y-axis. And all the points are circling around y-axis with that mirror image. So you have this solid shape which is created by rotating the given region around y-axis. Now we need to find the volume. So what you need to do here is find the cross section which is perpendicular to the axis of rotation. The axis of rotation is y-axis. Perpendicular to that, imagine you have like a saw cutting through the solid. If you cut through the solid, it's gonna give you a washer shape. Washer shape is an outer circle and an inside circle. Okay. So now we need to kind of find the area of this washer, which is here. So for that, we need to first find the outside radius. What is the outside radius? If this point is on the parabola y equal to x square, then x would be equal to square root of y. Okay, I'm only taking the positive part because it's on the first quadrant, right? So if this point is on this coordinate, the radius of the outer circle is the x value, and x can be found by taking square root is square root of y. So what will be the area of outer circle? Pi times root y whole square minus what will be the area of the inner circle. For the inner circle, the area is just this much. And this point is lying on the line y is equal to 2x. Therefore, the radius is x part. So x is equal to y by 2 from that curve. So area of the inside circle will be pi times y by 2 whole square. We need to integrate it from y values this and this. How do we figure that out? That can be found using the point of intersections of the curves. The curves are y equal to x square and y equal to 2x. We need to find the point of intersection. How do you find point of intersection? By equating the curves. X square minus 2x equal to 0. X factor x minus 2 equal to 0. X is equal to 0 and 2. So therefore this is 0 and this point here x value is 2. What is y value? Y will be equal to x square. So that will be 4. So therefore we are integrating from 0 to 4 with respect to y. This is your volume of your shape. Remember, the formula was volume of rotation. Volume of the solid of rotation is integral from a to b pi f of x whole square minus g of x whole square dx. If we are rotating about x-axis, that same can be converted into this if the rotation is about y-axis. So let's try to find the integral now. Pi can be factored out. 0 to 4. Root y square is y minus y square by 4 with respect to y. Pi is outside. Integral of y is y square by 2. Integral of y square is y3 by 3, and there is already 4 there. And we have done the integral, so the limits are written on right hand side. Pi upper limit minus the lower limit. When I put upper limit, it's going to be 16 by 2 minus 64 by 12. And when I put the lower limit, everything is just going to turn to 0. So we have this as pi 8 minus 16 by 3. Basically, that is 8 pi by 3. So this is your final answer, volume of your solid, which is created by rotating the region bounded by these two curves around y-axis.